in this tutorial, we'll follow descending tracts which bring information away from the brain. The main descending tract which we will be discussing today is the corticospinal tract, which carries axons primarily from the motor cortex of the brain to the spinal cord, where they synapse with motor neurons. From the cerebral cortex, the fibers of the corticospinal tract descend through the subcortical white matter, where they go on to pass through the posterior limb of the internal capsule, which we mentioned is located between the thalamus and the putamen. From here, the fibers of the corticospinal tract descend into the midbrain, where they travel within the cerebral peduncles and then continue on to the pons, before gathering into discrete bundles which form the pyramids of the rostral medulla. And as you can see in the illustration, the fibers are somatotopically arranged, with the more medial fibers belonging to the upper extremity and the more lateral fibers associated with the lower extremity. As they reach the caudal medulla, the fibers of the corticospinal tract separate into anterior and lateral divisions, and this occurs at the pyramidal decussation. And just a reminder, to decussate means to cross to the other side of the medulla. This is the anterior corticospinal tract, and axons within the anterior corticospinal tract remain ipsilateral, which means being on the same side, to the motor cortex they originated from into the spinal cord. And before these fibers synapse with interneurons in the spinal cord, they will cross over to the other side of the body, anterior to the grey matter of the spinal cord. And these fibers provide motor innervation to your back, as well as the proximal portions of the extremities, and they play an important role in maintaining posture. The axons of the lateral corticospinal tract cross to the other side of the body in the medulla at the pyramidal decussation, and these fibers supply motor innervation to the distal parts of the extremities, like your hand. This tract is a relatively recent evolutionary development and only found in mammals capable of performing skilled voluntary movements. Another white matter tract I would like to briefly mention to you is the corticobulbar tract. However, instead of controlling muscles in your legs or arms, the neurons in the corticobulbar tract control muscles in the head and neck. And because they don't need to travel lower than the neck, the axons in the corticobulbar tract do not enter the spinal cord. Instead, they synapse onto the nuclei of cranial nerves 3, 4, 5, 6, 7, 9, 10, 11, and 12. So basically, cranial nerves 3 to 12 minus number 8. And these cranial nerves contain motor fibers for the muscles of your eyes, face, the muscles of mastication, and some of the muscles of your neck. Something important to note is that the corticobulbar tract is sometimes called the corticonuclear tract, and this tract has actually been renamed because the word bulbar refers to the medulla. However, not all fibers of the corticobulbar tract actually reach the medulla, and it's more accurate to say corticonuclear, which instead refers to the cranial nerve nuclei.
If you found this quick anatomy or physiology video helpful, you'll enjoy our video tutorials even more. Click on the button and you'll see what I mean. We have hundreds of videos available to our premium members, not to mention all the fun quizzes, complete articles, and atlas sections to solidify your knowledge. Click on the button in the middle to watch the full-length video and master anatomy and physiology.